So let's take a look at question 14. All right. So an equation used in physics is work done is equal to force multiplied by distance. Okay. Lovely equation. Okay. It explains it here. W is equal to work done. F is force in newtons. And D is distance. Okay. Oh, excuse me. Work done on a moving car is given at 12,500 joules, correct to 3 sig figs. Okay. The car moves a distance of 12,215 meters, correct to the nearest meter. So the nearest meter, okay. So that means that it could be 215.5 or 214.5. Okay. Nearest meter means you'll just add zero point 0.5 to the value or take zero point 0.5 away. If it was the nearest 2 meters, or then you would add two, not two, you'd add 1 meter up and 1 meter down. Okay. So it says calculate the maximum and minimum force. Maximum and minimum force applied to the car. Okay, so we're gonna have to actually rearrange this equation first. Okay, so work done is equal to force by distance. Distance is multiplying by force on this side. So what it'll do in the opposite, it will divide. Okay, divide and conquer. Work done is equal to not work done divided by distance is equal to force. Okay, so force is equal to work done divided by distance. Okay, now let's think about it here. I'm gonna write max and I'm gonna write min, and then I'm gonna show you how I would think about if we're gonna work out the maximum. Okay, so work done distance, force equals work done and distance. Okay, so again, this is correct to three significant figures. So this value here could be, I'm trying to think, it could be 12,5,500 to 3 sig figs. It would still round down, or it could be 124,500. Okay. Correct to three significant figures. All right. So that would be our upper value, or lower value, LV or UV. Again, this would be our upper value or our lower value. Okay. So let's think about if we wanted the maximum force. Okay. Now distance, it divides. Okay. And if we divide by a bigger number, our answer would be smaller. Okay. So we would want to divide by a smaller number. Okay. So say for example I had 2 divided by 1. Okay. My answer would be 2. Okay, but if I divide by a smaller number, so 2 divided by 0.5, that would give me 4. Okay, so if I have a smaller distance, that would increase my force. Okay, just as an example. All right. And then work done's just in the top. Okay, so we just want it to be as big as possible, so we'll take the biggest value. So our force is equal to the greatest value of work done, which would be our upper value, which is, I have slightly butchered this, I've added an extra 0, excusez-moi. So it'll be 12,550. So it will be divided by the lowest distance, which is 214.5, and that'll give us the greatest force. Okay. I'm just gonna put everything in the calculator at the end. Okay, that's kind of the way I roll with these things. So let's look at minimum. So with minimum, if we have a greater distance, okay, again our force will be smaller. So I can give you the example of, say we had 2 divided by 1, that gives us 2. If I increase what's dividing on the bottom, so 1 to 2, it decreases my result. Yeah, so I had 2, now I have 1. Okay, so a bigger number on the bottom gives us a smaller force on the top. Okay, so we'll choose our upper value for our distance. And essentially for our work done, we'll want a smaller value. So I will, yeah, because we have a smaller value in the top, then we've got the smallest or the minimum that we possibly could have. Okay, so force is equal to the lowest value for work done, which is 12,450, divided by, excuse me, the greatest value on the bottom, which is 215.5. Yeah. So let's work out those two values. So first one is 12,550 divided by 214.5, and that's the greatest force that can be reduced is 58.5, and the minimum force is 47 or 57.77. Okay, so our maximum force is 58.5 and our minimum force is 57.77. Okay, hope that makes sense, and I'll see you in the next one.